Greetings, class. This is Stats, Psych211, also cross-listed with Soch211, and I'm Dr. Speck. And please let me know via email if you have any trouble with this video, or if you have any other questions at all. Okay. My email address is on the syllabus, which you should have gotten. So anyway, let's get started. This is one of my favorite courses to teach, and there's a reason for that, because it's a really nice skill to have. This is a marketable skill, this course. It's based far less in a catalog of factual information as it is learning how to do some techniques. So let's get started. Okay. A lot of people are scared of this course because they think it's a math course, and the way I conceptualize it is not as a math course, even though certainly we will be using math to do some of the procedures. Most of the math, I would assume, is not going to be new to you. High school algebra is what you need to know. If you have questions about that, if you're having trouble, please contact me. I can help you through that stuff. But we're not going to do much new math, okay? Another thing that I would like you to pay attention to is certainly the non-math parts of the course, because in a way, well, it's just as important as the math. I think it's more important. Once you get out of this course, and I can show you some of this later in the semester, once you get out of this course, you're going to be doing most of the procedures we're performing here. You're going to do most of those via a computer, okay? So pay attention to the concepts as well as, doing the problems, doing the computations. Because when I give you a test, there are going to be short answers and essays as well as the math portion. Okay, so I just want people to know that up front. And I will remind you repeatedly about the fact that this is not a math course. It's really a course in description or decision making. In fact, this first lecture, we're not going to do much math at all, but we're going to be talking about the concepts. And in some ways, this first lecture sets the foundation for everything else. So I'll be sort of going back to this lecture as well. It's not one of these fluffy sort of like, this is the first hour of the class, it's not going to be important. This lecture is extremely important to set up sort of the entire semester in a way, in terms of the rationale for why we're doing this. So one of the reasons I like teaching this course so much, in addition to the fact that it's a really powerful skill to have, a marketable skill, is that it is generalizable to lots of different majors. So this course is cross-listed with psych and sociology. It has been required for a variety of different majors, certainly required for psych majors, and weirdly enough, I think this is probably one of 3 courses that's common across all psych curriculum. It's also, when you go to graduate school, you're typically going to take 2 semesters of statistics. The good news is this course is almost like the first 2/3 of what you would get in a graduate program. So, I like having lots of different students in different majors in this course, and I'll be using lots of different examples from all sorts of majors to show you how generalizable these skills are to do decision making. So anyway, let's get started. Chapter 1 in the book is sort of a hodgepodge of a lot of different concepts. My advice to you is your primary source of information are these video lectures, okay? The textbook should act as a supplement to these lectures. So if I don't cover something that's in a chapter, that's kind of low priority for any kind of assessment. I didn't say no priority. I want you to read that information. But information that's both in the book and that we cover is the highest priority. Okay? And please pay attention. Also, another thing, please take notes when you're watching these videos. It's very important to take notes. That's what it's all about. Some professors provide notes for their students, and I personally think that's a disservice, because as you write information down, you encode it better in your brain. This is just straight up psychology, okay? So take the time to take notes. What's nice about video lectures is that you can go back and listen again, or rewind and sort of, check out the new information or whatever. But let's get started, okay? So, in a way, I'm, again, setting up the foundation for the semester, okay? And what we're going to do for the first maybe 1/3 of the semester is we're going to be talking about descriptive statistics, okay? Descriptive statistics. So, what do you think we use descriptive statistics for? Don't make it harder than it is, okay? It's already hard. You don't need to make it harder. Yeah, we're going to describe a data set, okay? And so we might do some kind of customer satisfaction survey for a company, and there might be 500 employees in the company. And so all of a sudden we have data from 500 employees. Maybe we ask them, how satisfied are you with the working conditions in this organization? And on a scale from 1 to 10 or something like that. And so we have 500 pieces of data, and your supervisor might ask you, so, what do the data look like? One of the things you don't want to do is sort of take this large data set of 500 points, right, 500 numbers, and say, well, here you go. Here's what we found. Your supervisor is going to be like, no, I want to sort of know, can you describe what we found? Are people generally satisfied or not? Okay? And so we're going to talk about techniques to describe large data sets. But we're going to be using mostly small data sets for our examples, because we're going to do a lot of the statistics by hand, okay? And I can hear the groans, right? It's good for you to improve your math skills, okay? So we're going to do small data sets in this class, but understand that everything we do in this class with the small data sets can be used for larger data sets, 500 numbers, 1,673 numbers, 5,236 numbers, okay? And we'll talk about different ways to describe a data set, and both as a producer of statistics, but also as a consumer, okay? Because as a professional, which I hope you all will become with your degrees, some level of professional. As a professional, you are going to rely on information to make decisions. Okay? Everybody with me? Because that really is going to set us up here for why the hell we're taking this course, right? Nobody wants to take this as an elective, and everybody's sort of scared of it. Listen, if you're going to be a professional, you're going to be basing decisions on information. Information is data, okay? So we first want to do descriptive statistics. So that's about the first third of the semester. And then probably the last 2/3 of the semester, we're going to be talking about inferential statistics, okay? Does anybody know what inferential means? right? It means to infer. What does that mean? And sometimes people say, well, it's to make a guess. And that's pretty close, right? I'm going to infer something. I have this information, and I'm going to infer. Well, here we have another sort of set of vocabulary words. Sometimes when we're seeking information, we have an incomplete data set. So suppose that we wanted to know what the average age of Utica College students is. All right? Well, we have two possible strategies to do that. We could ask every single student that goes to Utica College what their age is, and then we would have the entire population, okay? So we're going to talk about populations. We're going to talk about samples, okay? Populations, we refer to something as a population when we have all of the information that we're interested in. So in the case of the average age for Utica College students, if I ask every single student what their age was, then I would have all of those numbers. And then all I need to do is what? Describe, okay? So if I have, let's say, 3,000 students at Utica College, I have every one of their ages. I'm going to then get the average and describe that population, okay? The other strategy is to take some subset of the population. So let me take 500 students and ask them their age. That constitutes a sample of Utica College students. So a sample is a subset of the population. Now, if I only have 500 students, I don't really know what the average age of Utica College students is, but I can make a guess. That is, I can infer from a sample, okay? This happens all the time with political polling. So we can ask about the approval rating of the president, and news organizations will report the president's approval rating. But I guarantee you that they have not asked every single citizen in the United States. That's 325 million people. Of course, maybe we would only be interested in voting age population, but that still is, let's say, 200 million people. It would be virtually impossible to get that information, although we're trying to do it with the 2020 census, right? It'd be virtually impossible to do that with the entire population. So what these polling organizations do is they might interview 1,500 people, right? Now, what they want to do is they want to have some people from the Northeast, they want to have some people from the Southeast, they want to have some people from California, they want to have some people from Alaska, some people from the Midwest, and so on and so forth. We want our samples to be representative of the population, okay? We want samples to be representative of the population. Once I have my sample, then I can make an inference. So from these 2,000 people that a polling organization might ask about the president, they're going to then say, okay, so this is what we think the entire population is thinking about the president. And guess what? They can be wrong. I mean, that's just a fact. Anybody who has taken this course knows that when you have a sample that is some subset of the entire population, and you're making an inference, you can be correct in your inference, you could be incorrect in your inference. That's the nature of the beast. Only when you have the entire population can you then just simply describe what you see. And in a way, it's errorless as long as people are truthful, okay? The point here is, if we have the entire population, we can do descriptive statistics. If we're using samples to make guesses about our population, right? We're going to try to make guesses about the population. We're going to use inferential statistics. This is a much trickier thing to do. So we're going to spend a little bit of time, the first third of the semester, talking about descriptive statistics first, and then we'll get into inferential statistics. Okay? Again, not really mathematical yet, right? This is very important to sort of understand why you're even taking this course. Why are you taking statistics? Okay? And that is to learn how to do proper descriptive statistics, when we have an entire population, to learn how to do inferential statistics when we have some kind of a sample. Another thing about samples and populations, because sometimes students get kind of obsessed with having a definition. I want a definition. Listen, population, it's a hard thing to define. Just like east and west is difficult to define, right? If I said, is Utica east or is it west? What's the answer? Well, it depends on what you're talking about. It's a relative term, right? Same thing with populations and samples. Population is a collection of everything that we're interested in. I might want to know, what is the average age for my statistics class? In that case, it would be relatively easy to do that. You know, if I have 25 students or 50 students or 75 students, I could get that information. And that becomes, if that's the only thing I'm interested in, that is my population. See what I mean? Population is not defined by size, it's defined by what you're interested in. If I just want to know the average age of my stats students, I could probably collect those, the entire population, then describe. But if I want to know the average age of Utica College students, that's going to be a lot tougher. I might use my stats class as a sample to describe that population of Utica College. So my statistics class is a population if that's the only thing I'm interested in. If I'm interested in Utica College students, my stats class becomes a sample. I might want to know what's the average age of students taking college classes in the United States. Well, then I might use my stats class as a sample of college students in the United States. Okay? Sample is just a subset of a bigger group. Population I define as whatever it is I'm interested in for my research or for whatever it is I'm doing. Okay? All right. Let me move on here. One of the things that we find is this course is certainly required for psychology majors, but it's cross-listed with Soc. It's also, we have nurses taking the course, biologists, physical therapists, occupational therapists, as well as a number of other folks, okay? But what, I kind of group these together sometimes as the therapeutic professions, okay? So whether we're talking about psychology, or we're talking about nursing, or we're talking about OT or PT, anything in healthcare, even education, I might add, we could maybe throw in there, quotes, as therapeutic. What do these professions have in common? What do these professions have in common? OT, PT, psychology, nursing, medicine, therapeutic rec, education maybe, but what do they have in common? Well, here's what I would suggest they have in common. That's delta, and that represents what? Change, right? That represents change. I mean, really what we're trying to do is see a change. That's why I put education in there as well. If I'm a physician, I'm going to try to make the patient better. What does that mean, make the patient better? Well, if they have a high fever, I want to administer some medication that brings down that fever. Okay? And when I say brings down, I'm looking at a change, right? Or a difference. So when they came in, they had a temperature of 102 degrees. And after the medication, we saw that it went down to 98 degrees. Okay? So that constitutes a change. If I'm a psychotherapist and someone comes in my office and they have test anxiety, I would want to work with that person so that their high level of anxiety, the next time they take an exam, that would change, right? That it would be lower after my therapeutic intervention, okay? If somebody comes into physical therapy clinic and they can't move their elbow, I can't move my elbow, right? I would want to do whatever it is that physical therapists do, some kind of exercise or an injection of a steroid or whatever it is, so that after 3 weeks of therapy, the person is then able to move their arm without pain. Okay? So this is what I'm talking about when I talk about change or talking about a difference. With education, it's all about difference, right? I mean, I hope that once you finish this course, that you will be a different person in so much as you can do these statistical analyses, to do some descriptive statistics, to do some inferences, to be able to make some decisions. Okay, so all of these sort of areas I put into one bucket here, the therapeutic professions, and I want to be able to detect a change. Okay, now I know that not everyone that's taking this class is in one of these therapeutic professions. I'm hoping that maybe there's a history major or a communications major, a couple of majors that I've had in this course before, taking it as an elective, which really makes me happy. But most people are taking this course as a required course or as a prerequisite for something else. I would also encourage you, especially psych majors. I mean, the psychology faculty in the department at Utica College can make any kind of requirements for the major they want. And all of us, and this is pretty much across the country, you'll see this in psychology departments, all of us have agreed that this course is so important that it's one of the few required courses in psychology. So I would like you to think about that a little bit. Instead of, sometimes people say, well, I don't think it's important. That's okay if you want to believe that, but I would caution you because the entire psychology faculty thinks that this is an extremely important course. I hope that you understand from today's lecture why we think it's important. We really want to be able to detect this. We really want to be able to say, hey, we have a decrease in our body temperature after we administer the drug, or after 4 weeks of anti-anxiety training, these people were able to go into an exam without as much test anxiety. I want to be able to see that change, or I want to be able to say, yeah, after the physical therapy, we had a much better range of motion. Okay. If you're not in the therapeutic professions, certainly you might be interested in change and difference. Any kind of research endeavor, so if you're psychobiology, biology, animal behavior, chemistry, any of this stuff, what you typically are doing is setting up an experiment and trying to see if there's a change, right? If I put more calcium in the bathing solution for the neurons, will they fire more, right? Is there a difference? Okay. Or do I see a change after I put more calcium in the solution? Okay. If you're in business, you might, some of the examples I use, if you have a celebrity spokesperson for your product in advertising, is it worth the money? You know, if you spend $1 million to get a celebrity spokesperson, are you going to see a difference in the sales of your product? Okay. This is how valuable and how generalizable these skills are. Okay. So this is really what we're talking about here, and it really sets us up. This is the foundation for the rest of the course. Okay. I want to be able to detect differences, or I want to be able to detect changes between two groups or with an individual going before therapy, after therapy. Okay. I hope that your education has created changes in you that you can then use. Sorry about that. I'm doing this at home. Got a little FedEx visitor. Anyway, that you can detect these changes. Okay? All right. So, when we talk about change, or we talk about differences, of course, now I'll ask you the mathematical question. What mathematical function would you use to detect a change or a difference? Which mathematical function? Who knows? And of course, when I ask this question, it starts freaking people out, okay? And that is because I use the term mathematical and function. What mathematical function would we use to detect whether there's a change? Well, or a difference. Let me ask you this question. Are you shorter or taller than your mother? Okay, so people are answering this question. And I would say, well, if you said yes, you're shorter than your mother, how would you demonstrate that? Well, you get your height, right? You get your mother's height. What mathematical function would we use? We would use subtraction, right? So if the difference is 0, then you're the same height. If the difference is something other than 0, then there's a difference. And it really, you can say there's a difference. It's like, is your mother taller than you, or are you taller than your mother? Well, it would depend on who is subtracted from whom. Is that right? Okay. But here's the mathematical function right there. Difference. Difference. Okay? Subtraction. That's really what we're talking about here. Don't get like that deer in the headlights thing when we talk about math. I'm going to help you with that. Okay? I'm going to pose questions. When I pose questions, even though it's through this video, I'm going to hesitate, give you some time. I want you to think about this. Statistics and education is just not about dumping things into your head. This is not just a catalog of factoids. It's really, I want to get you thinking about this stuff. If you think about it, you think about the concepts, it will be easier Sometimes I think students just want to memorize stuff and they think that's easier. I'm like, man, my brain just doesn't work like that. I don't have enough room, enough memory, enough space. If I understand the concept, then I can generate some of these, some of the specifics. All right. So really, what we're doing here is subtraction. Has there been a change? When you came in, every time you took a test, you got all sweaty and nervous and your heart rate went up. After we went through the therapy, we saw that you could go into an exam and maybe you were sweating a little bit, but you were able to calm down and there was a change in your anxiety. Or we could say that there's a difference. Okay. The way that we could get to that is do subtraction, right? So maybe your heart rate before therapy, your heart rate when you were taking exam was 88 beats per minute. And after the therapy, you got that down to now 78 beats per minute, okay, on average. So we had a 10 beats per minute change, okay? We had a 10 beats per minute difference. That's what I mean. How do you get that? Just do subtraction, okay? That's how we got to that. That's all. So if we're looking at change or we're looking at differences, one of the things that we're going to be concerned about are variables. Now, what is a variable? See, now I hesitated there, and if you're like most students, you kind of just didn't think about it or a little bit scared maybe, because variables, all of a sudden, that sounds like science to me, and people get a little bit crazy with math and science. What is a variable? What is a variable? It's right in the name, right? Anything that's able to vary. Hey, you guys, this course will get more difficult, but please don't underestimate how important it is to have these very basic facts, because I'm going to get back to those. I mean, I will refer to this first class as we make our way through the semester. Anything that's able to vary, right, is a variable. Heart rate, yeah, that's a variable. Body temperature, yep, that's a variable. Ability to move my arm, yep, that's a variable. My golf scores, yep, that's a variable. Neurons firing in a calcium bath, yep, that's a variable. Serotonin levels in the raphe nuclei of the brainstem, levels of serotonin. Is that a variable? Yep, that's a variable. But see, as soon as I start talking about that, people start getting intimidated. You don't need to be intimidated, okay? We're just talking about anything that can vary. How about this one? What is the opposite of a variable? Yep, some of you got it, right? So the opposite of a variable would be a constant, something that does not vary, does not change, okay? And constants, I mean, they're important, right? The force of acceleration of gravity, boiling point of water, of pure water, distilled water at sea level, what is E equals mc squared, right? That constant in the Einstein formula, and so on and so forth. They might be important, but typically I'm really more interested in variables, things that can change or be different. That's really what we're after, especially in the therapeutic professions. Okay? Everybody good? Okay. Like I said, in order to detect a change or to detect a difference, we're going to use, straight up folks, subtraction. Okay? But in order to do subtraction, I need to have the variables be quantified. That is, I need to have numerical values for my variables. I mean, I'll give you an example. I mean, let's do this. Okay. Let's do this. Anybody know what that is? Yeah, it's a bunch of grapes. Okay. And a bunch of grapes, and then let's do this. Well, it's supposed to be an apple, okay? Bunch of grapes minus an apple equals what? Equals what? How the hell do I know, okay? I mean, that doesn't make any sense to talk about this because I can't really subtract apple from grapes and get anything meaningful, right? Is there a difference between these two things? Yes, but I really don't have any way of quantifying that, okay? And so if I change this and I said, well, I have 5 apples yesterday and today I have 2, then there's a difference, right? A difference of 3 apples, okay? So once I have a quantity, I can then do a difference. Until I have a quantity, I can't do my subtraction. This is an extremely important point because if I'm interested in things like anxiety, depression, I'm going to do a nice one in here too. Happiness, intelligence, right? If I'm interested in those kinds of variables as psychologists are interested in, I'm going to need to find a way to quantify these variables. I'm going to need to find a way to quantify these variables. And by the way, these are psychological examples, but we also have business examples, right? I mentioned this before. What about customer satisfaction? Boy, I hope you're interested in customer satisfaction if you're running a business. This would need to be quantified then for us to be able to see if there's a change or a difference depending on what you have on the menu or how quickly you're getting people's phone calls or whatever that might be, okay? In medicine, we have things like pain, okay? I need to quantify pain if I want to know if there's been a difference, okay? A lot of these variables aren't physical variables. That is, you can't really sort of just lay them on the table and measure how long they are or put them on a scale and measure how much they weigh, okay? And so we're going to talk about this a little bit more. I need to subtract to get difference or change, okay? And with some of these things, it's difficult to subtract because it ends up being like the grapes and the apple, right? They're concepts. They're not something that's numerical. So a couple more vocabulary words here. We're going to talk about hypothetical constructs, okay? What does that mean, hypothetical construct? Well, things like intelligence, creativity, anxiety, depression, jealousy, customer satisfaction, pain, due diligence if you're a lawyer. All of these are hypothetical constructs. What is a hypothetical construct? Well, it's an idea. It's a concept, even though we call them constructs, right? Like happiness, you know what I'm talking about when I say happiness. But I can't like go into somebody's brain and just pull out, oh, there's their glob of happiness. It's a hypothetical construct, right? Happiness is hypothetical. And so what we need to do is take the hypothetical construct and to convert it into something that we're going to call an operational definition. Okay? Now, here's how it works. I have something like test anxiety as my hypothetical construct. If I'm a therapist and I have a way that I think I can reduce test anxiety, then I'm going to do that intervention, and then the person takes the exam, and then I want to see if there's been a change, if there's been a difference, okay? But I want to quantify that. So one of the things I might do is I might look at heart rate. So I might use heart rate as the operation that I use to define test anxiety, okay? So this might be my hypothetical construct. It doesn't exist in any physical, real, tangible terms, but I'm going to need to do something to quantify the variable. So this ends up being my quantifying, this is my quantifying step, or this is how I'm going to measure the variable. So test anxiety might be my hypothetical construct. I might do heart rate, beats per minute, as my operational definition for test anxiety, okay? And so I might have, what did I say before, 88 beats per minute, and then it went down to 78 beats per minute. So now I can say there was a 10 beat per minute change in my test anxiety, okay? That's how I'm going to define it. That's operations I used to define it. Alternatively, I might say, well, let's look at something called the GSR, the galvanic skin response. Okay? By the way, this is part of a lie detection test, the GSR, galvanic skin response. What does it measure? It measures the amount that you're sweating. It measures the amount that you're sweating. You actually get a value here. So maybe your GSR before therapy was 27. Sorry about that, folks. Doing this at home, getting lots of interruptions. Your GSR might be 27 before the therapy, and then it might go down to 15 after the therapy. Let's say that means you're sweating less, right? And so that means we had a 12 point difference. That represents a decrease in test anxiety, okay? As long as we have a quantifiable measure, we can do our subtraction. As long as we have a quantifiable measure, we can do our subtraction, right? Until you have that, we can't. Let's do our customer satisfaction, just see how this works. So here we have, I want to know customer satisfaction as my hypothetical construct. I want to get some kind of measure of that, okay? Now, we could do a survey and say, on a scale from 1 to 10, how satisfied are you as a customer? And let's say before you imposed your new phone answering system, people had an average of 6.75, and afterwards it went up to 9. And so now we can see that there's been a difference. People are more satisfied, okay? Or, this is the fun part, trying to figure out what kind of operation we use for customer satisfaction. Maybe we could do number of repeat customers in a year. Okay, so how many times do people come back in a year? If 2019 we only saw this many repeats, and in 2020 we see this many repeats, well, then that means there's been a difference. Okay, it's something that we can quantify in our measurements. Okay. For psychology majors and for some of you other folks too, your next course will be a research methods course. For psychology, it's our next course after stats, and we spend lots of time going through this. How would you take a hypothetical construct and create an operational definition for that so that you could measure changes or differences? Now, I do want to talk about variables a little bit more because in some ways they come in two flavors that I want to talk about. One are continuous variables, and the other is discrete variables. Okay? And this shouldn't be new vocabulary for most college students, but it is for some, okay? What does discrete mean? Well, like things that come in sort of discrete packages, right? And we can talk about variables that are discrete variables, like the number of teeth that you have, okay? Maybe you have, I don't know what the normal number of teeth is. It 32? It seems like a lot. 32? Maybe it's 32. I should look that up. Number of teeth that you have. It's a discrete variable. I mean, you either have 32, or you have 27, or you have 16, or whatever it is. I'm sort of ignoring people to get a chipped tooth or any of that kind of stuff. Okay, just to make it clear, that's discrete. Or I could say the number of children in your family, okay? There's either 1 or 2 or 5 or 7, okay? There's not 2.36 children in your family. Now, when the census is done, they might say the average American household has 2.37 children. Well, that's the average. But of course, nobody has 2.37 because number of children in your family is a discrete variable. It can only take on certain values. That's what discrete means. 0, 1, 2, 3, okay? Number of cars that are in your household. You have 1 or 4 or 3. Those are discrete variables. We're going to mostly, though, talk about continuous variables, okay? So these are variables that can take on any one of a number of values, and between any two levels, there's an infinite number of other levels. And between these two, there's an infinite number. And between these two, there's an infinite number. That is, we sort of have a number line, okay? If we talk about pain, I would consider pain as a continuous variable. I mean, I'm in a lot of pain, and when I took aspirin, it made it come down just a little bit, but it doesn't sort of move in packets, right? So pain would be a continuous variable. I would think that intelligence is a continuous variable. That is, you could be just a little bit more intelligent than me, or you could be a lot more intelligent than me. And between you and I, there's an infinite number of spots where people could be in terms of their intelligence. Depression does not come in packets. Okay, we assume that it's on a continuum. Okay, that it's a continuous variable. Okay, as opposed to discrete, which can only take on certain values. Okay. Continuous temperature would be continuous. The amount of fluids that you drink in a day is continuous. The height of a bean plant would be continuous. Okay. Discrete, number of children, number of teeth that you have, number of cars that went past a certain spot on a highway, number of pets that you have, right? Those are discrete. Most of the time, though, we're going to be talking about continuous variables. So we're going to end it there, and in the next video, we're going to sort of use an example of a hypothetical construct, come up with some operational definitions that we can use so we can look for differences, and then we'll start doing some basic math. But please, I hope that this sets up the foundation of why we're doing statistics in the first place. If you don't understand that, the course becomes kind of weird because you're just doing things, okay? But I'll remind you as we make our way through the semester that we're really describing, making inferences, making decisions based on information, based on data, right? I mean, sometimes people get a little weirded out with that word too. Data just means information. I mean, I'm going to make my decisions based on information, not just based on nothing, based on opinion, okay? That's not how I want to do medicine. That's not how I want to do science. That's not how I want to do therapy. I want to make sure that we have information, that we have data that suggests that our therapeutic intervention is actually helpful. Okay, we'll see you next time.